Ok. Obrigado.
Boa tarde a todos. Boa tarde a todos. Estamos dando seguimento com o Seminário de Teses do Programa de Pós-Graduação em Sociedade, Natureza e Desenvolvimento de 2020. Vamos agora para a nossa keynote speaker, que seria a palestra de abertura. Em decorrência do fuso horário, a gente teve que colocar essa palestra agora às 14 horas. E temos o grande prazer de receber a professora, a doutora Elisabeth Bik. Eu vou passar a palavra ao meu colega, o professor Troy Beldini, professor permanente do PPGSND, que ele será o host da nossa anfitrião, da nossa apresentação de hoje. Professor Troy, muito obrigado por aceitar nosso convite. Eu passo a palavra para o senhor.
Ok, obrigado. Boa tarde a todos. Eu vou apresentar a doutora Bik agora. Eu vou falar sobre a biografia e o resumo sobre a palestra dela hoje, né, o trabalho dela. Eu vou falar primeiramente na língua inglesa e depois eu vou falar em português, tá? Okay. So good afternoon, Dr. Bik. It's excellent to have you here with us today. It's a real honor, and I think that we're going to learn a lot about improper behavior in scientific publications. So I'm going to present you now. After receiving her PhD in microbiology at Utrecht University in the Netherlands, Dr. Elisabeth Bik worked for 15 years in the lab of David Relman in the School of Medicine at Stanford University on the microbiomes of humans and marine mammals. In May 2014, she founded Microbiome Digest, an almost daily compilation of scientific papers in the rapidly growing microbiome field. From 2016 to 2019, she worked at 2 microbiome startup companies. In March 2019, she left her job to become a science integrity volunteer and occasional consultant. She can often be found discussing science papers on Twitter at Microbiome Digest, writing for her blog Science Integrity Digest, or searching the biomedical literature for inappropriately duplicated or manipulated photographic images and plagiarized text. Her work has recently been featured in Nature. Agora, em português, a biografia profissional da doutora Bik. A doutora Bik, após receber seu doutorado em microbiologia da Universidade de Utrecht, na Holanda, trabalhou 15 anos no laboratório do Dr. David Relman, na Escola de Medicina de Stanford University, estudando os microbiomas dos humanos e os mamíferos marinhos. Em maio de 2014, ela fundou Microbiome Digest, uma compilação quase diária de artigos científicos do campo de pesquisa sobre microbiomas, que está em pleno crescimento. De 2016 até 2019, ela trabalhou em 2 empresas startup que estudavam microbiomas. Em março de 2019, ela saiu do seu emprego para tornar-se um detetive investigando a integridade na ciência, trabalhando numa forma voluntária e realizava consultorias periódicas. Ela muitas vezes está discutindo artigos científicos no Twitter em @microbiomedigest, escrevendo para seu blog Science Integrity Digest, ou vasculhando a literatura científica para achar imagens indevidamente manipuladas ou duplicadas e texto plagiado. Seu trabalho foi recentemente destacado na revista conceituada Nature. Ok, agora vamos para o resumo. Ok, Dr. Elisabeth, now we will read the abstract for your work today, your talk. The title is The Dark Side of Science, Misconduct in Biomedical Research. Abstract. Science builds upon science. Even after peer review and publication, science papers could still contain images or other data of concern. If not addressed post-publication, papers containing incorrect or even falsified data could lead to wasted time and money spent by other researchers trying to reproduce those results. Several high-profile science misconduct cases have been described, but many cases are yet undetected. Elisabeth Bik is an image forensics detective who left her paid job in industry to search for and report duplicated and manipulated images in biomedical articles. She has done a systematic scan of 20,000 papers in 40 journals and found that about 4% of these contained inappropriately duplicated images. In her talk, she will present her work and show several types of inappropriately duplicated images and other examples of research misconduct. In addition, she will show how to report scientific papers of concern and how journals and institutions handle such allegations. Ok, agora, gente, eu vou falar em português, eu vou ler o resumo em português. Título da palestra hoje: O lado escuro da ciência, má conduta em pesquisa de biomedicina. A ciência é construída em cima da ciência, ou seja, em cima dos achados anteriores. Mesmo após a revisão por pares e a publicação, artigos científicos poderiam conter imagens e dados de qualidade ou origem duvidosa. Se não forem corrigidos após a publicação, essas imagens ou dados poderiam causar um estrago enorme com respeito ao tempo e dinheiro investido por outros pesquisadores que tentam reproduzir estes resultados falsos. Apesar de já ter acontecido vários casos de má conduta de alto perfil, muitos desses casos provavelmente passam despercebidos. Elisabeth Bik é um detetive forense de imagens que renunciou ao seu emprego na pesquisa microbiológica para dedicar-se à busca e divulgação de imagens manipuladas e duplicadas na literatura biomédica. Até o momento, ela já fez uma revisão sistemática de 20 mil artigos em 40 periódicos científicos e achou que por volta de 4% desses continham imagens indevidamente duplicadas. Na sua palestra hoje, ela vai apresentar o seu trabalho e mostrar vários tipos de imagens indevidamente duplicadas e outros exemplos de conduta científica imprópria. Além do mais, ela vai mostrar como alertar uma revista sobre um artigo que mostra sinais de imagens ou dados indevidamente usados e como os periódicos e as instituições podem lidar com tais alegações. Ok. I think then we can hand it over to Dr. Elisabeth Bik to begin her talk. Please, Dr. Bik.
Thank you so much, Troy, for that lovely introduction in both languages. I could follow most of it, but I guess I'd written it myself, so I could follow what it was about. All right, let me set up my screen sharing. Start the presentation. So can you see my screen? Just checking.
Yes.
Okay, great. So yeah, here's my talk. Here are the two websites that I run. So sort of showing my split personality as both a science integrity worker, but also staying true to my old profession, microbiome work. And I am on Twitter at microbiome without the E digest. So that's my Twitter handle. I also want to make sure I disclose how I earn my money because I am a consultant. And so I will earn some money by consulting for science integrity cases and microbiome analytics at publishers and universities. And I also sometimes receive speakers honoraria for seminars, usually by universities and research institutions. My name is on 4 uBiome patents. I doubt that I will ever make money because Biome went bankrupt and is now involved in a big scandal. So I don't think these patents are worth any money. And I have a Patreon account, which is where people can donate money to me and support my work. I also would like to thank a lot of people who do very similar work to what I do. So I am sort of a whistleblower. I will look at images in scientific papers and report them, but there's a lot of other people who do similar work, and some of them work anonymously and some of them work under their full name. But together we're sort of people who care about science and who will report this. So I want to thank all the people who are mentioned here and for their work. And some of the work I will be presenting is also the work they have been working on. So I'm gonna mute you, Troy, so because I think I hear some noises. So why do I care about science papers? I care about science papers because scientific papers are the output of scientists. And I see our output, our publications, as building blocks in the great brick wall of science. So if you think of each science paper as a brick in a wall, every generation of scientists will put another layer of bricks on that. Every scientist will look at previously published research to build their research on. So if one of those bricks or one of those publications contains an error or contains even fraud, it might be very hard to replicate or reproduce that work because it never happened. And so if a science paper contains an error, even after publication and peer review, there's still a chance it contains errors or maybe fraudulent data. I care about that because other scientists might be wasting their time and money trying to replicate those results. Now, most science is built on trust, and most scientists are honest and do great work and produce papers the best they can. But science as a field is not immune to fraud. There is fraud, like there is fraud in other fields, like, I don't know, banking or financing. Science as well contains a tiny sliver of fraudulent data. And in the United States, there's the Office of Research Integrity, ORI, that oversees federally funded research, specifically research funded by the National Institute of Health. And they define science misconduct as one of three things: plagiarism, falsification, and fabrication. Plagiarism is stealing somebody else's ideas or sorry, I'm getting a lot of peeps and beeps, so I don't know what's going on, but maybe somebody else can fix that. So plagiarism is stealing somebody else's ideas and not giving credit to that other person. So it's either ideas or literal text that somebody else has wrote, and not quoting, not putting that between quotes, or not citing and not acknowledging that those words have been written by somebody else. So that's plagiarism, and that's considered science misconduct. You always need to present original wording and original data. Then falsification is where a person does an experiment but leaves out or changes particular data. So you might get an outlier that doesn't fit in your calibration curve, for example, or you might a person who changes the values. So instead of the values that they had measured, they increase or decrease certain values and report that. So that's called falsification. While fabrication is where an experiment did not happen at all. Somebody just made up their data and drew some points on a spreadsheet or in a plot program and publishes that, but without actually doing the experiment. So there's no measurements at all. So those are the three big categories of science misconduct, according to the American ORI definition. There have been several famous cases of science misconduct, cases you might have heard about, cases that a lot of internet Wikipedia sites have been written about. And I want to mention 4 of them to show you that science misconduct can happen in any field in science and by any type of person at any type of institution. and in any country. So the 4 examples I've picked here, and I have not worked on any of these examples myself, but the 4 examples are, the first one is Andrew Wakefield, who was a doctor in the United Kingdom, in the UK. He worked in medicine, and he claimed that certain vaccines caused autism in small children. But it turned out that he had falsified some of his data. He had changed some of the dates at which these children got their first autism-like symptoms. And so he claimed that they got their symptoms after they received the vaccine. Well, in reality, they already had some of these symptoms before they got the vaccine. So he changed some of the dates. He changed some of the pathology reports. And so his paper, after a long discussion that lasted about 12 years, finally his paper got retracted. But still, a lot of people believe that that vaccines cause autism, even though there have been many other papers after the Wakefield paper that proved that there was no correlation between these 2 things, between vaccines and autism, with tens of thousands of children. So there's no proof at all, except this one paper that is based on falsified data. So his paper, even though it got retracted, still has a very long-lasting effect and might have even cost lives, because some parents do not vaccinate their children based on this one paper that got retracted. In the United States, there was a case of Jan Hendrik Schön. He worked at Bell Labs, and he worked in physics on semiconductors. And he turned out that he completely fabricated his results. He made up data, and he published the same graph a couple of times in different papers. Somebody saw that, noticed that, and then his papers got retracted. So it turned out that he completely faked his data. And so in Japan, there was the case of Haruko Obokata, who worked at the Riken Institute, and she claimed that she could make cells pluripotent by dipping them in an acid bath. Somebody noticed that some of her figures had been reused to represent other experiments. And finally, her 2 papers that got published in Nature both got retracted. And in the Netherlands, where I am from, we had, the whole country was sort of shaken because of the case of Diederik Stapel, who worked in psychology. And it turned out that he completely fabricated data. He made up a lot of papers and a lot of studies, and he has now 58 retractions. So 58, he is in the leaderboard of Retraction Watch, which is a website that follows retractions in scientific papers. And so these are some cases, and I have not been involved in any of these. But I work specifically, the type of work that I do focuses mainly on images in scientific papers. And so here I have a couple of examples of photographic images that you might see in certain scientific papers that could look like any of these. These might be photos of tissues or cells or gels or blots. And all these photos are fine. There's nothing wrong with them. And they're just to show you that the photos might show very similar tissues or might show very similar blots or gel bands. But each of these photos, each of these bands and each of these cells look unique. We can tell them all apart. So these are all fine. But what I do is I look at these images and I look for repeats, for images that either overlap or look identical to each other. And that would not be good, because you would not expect that 2 different experiments would yield the same image. And yet I have found in a lot of scientific papers, I have found examples of duplicated images like the one I'm showing currently. And I'm showing here 3 different types. You can see 4 different photos, but there's 3 different types of duplications that I've found during my searches. So if we start on the top left, you see a bunch of panels that all look similar to each other, but there's actually 2 pairs, and I've marked these in red. I hope you can see my cursor. So there's 2 panels here that look identical to each other, and there's 2 other panels that also look identical to each other, even though each of these panels is supposed to represent a different experiment or cell line. And so I call this a simple duplication. It's the exact same photo used twice. And this could just be an honest error. Somebody just did not label their images correctly and just grabbed the same photo twice to represent two different experiments. So it's sloppy, it's an error, but it's not necessarily science misconduct, but it is a duplication, and that is what I'm looking for. So here on the right of the slide, I have two examples of what I call a reposition duplication. So it's a duplicated image, but there's a shift or a rotation or a flip, a mirroring, things like that. So for example, if you look at this image here on the top right, you see 4 different photos. Each represents cells being treated with a different amount of radiation. And you see that 0 and 2 gray, these two images show an overlap. You see the same cells here and here in both of these panels. And the 2 panels here on the right also overlap. If you focus on this group of cells, you can see that here too. And so here's an example of where the sample has been moved under the microscope a little bit. There's also some stretching going on here. And so this is strange because you would expect 4 different photos, but we're only seeing at best 2 different photos. And here's another example of a Western blot where you can see an overlapping set of 2 panels marked by me here with red boxes, even though they represent 2 different cellular locations and 2 different proteins. And they're shifted 2 lanes to the left or to the right. And if we move on to the bottom left of my slide, you can see an example of what I call a duplication with an alteration. And in this particular case, you see 4 panels. And in panel A, you see that lane 1 and lane 3, marked by me with blue boxes, appear to look identical. While in panel D, 3 lanes marked by me with red boxes appear to look identical. So this appears to be a photoshopped image. So you can see unexpectedly that the same lane appears 2 or 3 times in the same photo, and you would not expect that in a natural photo. So if we think of the simple duplication as most likely to be an honest error, we can think of the altered photo as most likely to have been done intentionally. So that's very unlikely to be an error, and it's very likely that the author has done this intentionally. So I started this as a hobby, doing this in my free time, scanning papers for duplications. And I sort of turned this into a real science project by finding my 2 co-authors to be willing to complete this project with me, Arturo Casadeval and Frederik Feng. And the 3 of us, I scanned all the photos, I scanned all these papers, and they both had to agree with me to make sure that I wasn't just calling out a duplication and making an error myself. So I wanted to make sure that 2 other persons, and both of them are editors-in-chief of journals, that they both agreed with me. So I scanned more than 20,000 biomedical papers for these types of duplication. And I made sure to include 40 different journals from 14 publishers. And I covered about 20 years of publishing. And I scanned all of these by eye. So I only look for the images. I don't try to really understand the papers. I just scanned for duplicated images and only scanned for papers that had at least 1 photo, and only picked papers that had inappropriate image duplication. So if a image was shown twice, but it represented the same experiment, I would not call that out. But if it represented 2 different experiments, then I would call that an inappropriately duplicated image. And so in that set of 20,000, I found 800 papers with duplicated images that were problematic. So that's 4% of these papers that contained images with duplications. Because I had these 3 different types, we sort of guessed that about half of these duplications might have been done intentionally. It's hard to say it for an individual paper, but for this whole set of 800 papers and duplications, we estimated about half of these to have been done intentionally. Now, it's also important to realize that the human eye and brain can easily see these duplications, at least most people can, but if you think about alteration or duplications in other types of figures or data that could be present in papers, such as tables or line graphs, those might be much harder to detect. So we can see duplications in photos, but it's much harder to detect any manipulation of data that is presented in a table, a line graph, sequencing data, things like that. It's much harder to detect misconduct there. So the real percentage of misconduct might not be 2%, but might be higher, might be 5 or 10% of papers. So that's actually a pretty staggering numbers, that if 5% of scientific papers contain misconduct, it's very likely that you might come across a paper with misconduct during your literature searches. So it's something to be aware of, that if you don't trust the data, you might actually be right and there might be something wrong with this paper. Don't automatically trust all papers. So I have a couple of examples here, and it's hard to do audio audience participations in this setup, but I want you to look at this image for a couple of seconds and see if you see a duplication here. And there are several duplications, and I'll show them in the next slide. So you see 4 different or 8 different photos, and they represent different animals, but there's actually an unexpected duplication, and there's actually 2. If you look at this, you can see that this image here and this image here appear to show the same photo. And similarly, on the bottom row, you can see that this photo and this photo also look very similar. If you focus here on these little bulges here, you can see them here too, except that here there's a couple of green dots added that do not match the photo here on the left. So this paper got published in 2010. I found this duplication in August 2014, and I wrote to the editor-in-chief, and they decided very quickly, like within a month, to retract this paper. So it had been cited by 20 other papers, but yeah, this paper got retracted, and yeah, that's I think that's a good outcome, in particular because there's green dots here added. So there seems to be just an alteration to the photo as well. So this would be a type 3 duplication. Now here's a bunch of histology panels, and as you can see, they're different different staining, different antibody staining, and there's different treatments. So each of these panels should look unique, but yet there's a lot of overlapping here. And after working on this photo for about an hour, I marked it as this. So there's a lot of duplications, and I marked them with boxes of the same color. For example, this photo looks very much like this, so that would be a type 1 duplication. Well, there's also a bunch of overlapping panels, so that would be a type 2 duplication. This is way more than I would expect to be the result of an honest error. If a lab is this sloppy that they mix up photos, I would not trust any other photo or any other data from their paper or from their lab in general. And so this paper, I reported it to the editor of the journal in February 2015, and it got retracted in October 2015. So a couple of months. It was cited by 17 people, but 70 other papers. So I guess all these other folks did not see that there was a lot of duplications going on here, but I think the retraction of this paper is a good outcome, and it's still available, but it still tells people that you have to be very careful in interpreting this data or relying your research on this. Now here's another example of a type 3. This is a type 3 duplication because there's appears to be a lot of photographic manipulation going on here. If you, for example, look at these 3 cells here, you can see that they're also present here, but like this cell here is gone and there's replaced by 2 red cells. If you focus on this group of cells here, you can see that here, but in mirror image. And there seems to be some manipulation going on of this photo. And I've marked it here, and you can see that groups of cells appear to have been moved. And yeah, I would not trust anything associated with this photo. I did not put the paper here because this paper is still out there. I wrote to the editor, but the editor the editors decided to not address this. So this paper is still out there, and that's frustrating because I think somebody should warn the readers that there's a big problem with this paper. And unfortunately, the editor did not really feel the need to respond to this. Here's another example in which there's a big problem, and this, if you focus on these 2 lanes here, you can see here a little scratch And you can see that here as well. And you can see another example here. And so I have marked this photo, these two figures like this with red boxes. And it appears that these two lanes have been duplicated and used another time. And each time they represent a different experiment. Now, this paper was published in Science. So that's a big journal, right? And it was cited 830 times. There's 800 papers that use this paper, that base their research on this paper. I reported this to the journal. I wrote to the editor-in-chief of Science, and I said, this paper appears to contain a big problem, but they never responded to this. They never acted. So it's still out there. It has not been corrected or retracted. And it's frustrating for me that the journal does not take any action. And a lot of people have not seen this, but I feel that this is a big problem and I would not trust this paper. So what do you do if you find a paper like this? The best way to do it, or the official and professional way, is to contact the editor-in-chief of the journal and write to them and write, mark an image like I just showed it to you, and write to them and say, this is what I'm seeing, like figure 2A looks very similar to figure 3B. But it is important to remain objective. So if you say that one figure looks unexpectedly like another figure, that's objective because you sort of, nobody can disagree with you. But if you, it's important to not move any further, not make any accusations. So don't say this is fraud or this paper should be retracted. Just say it factually, state what you see, and leave it up to the editor to contact the authors and start an investigation. So they might ask the authors for the original blots, for example, or the original photos, and then the author can respond. And maybe I'm misinterpreting these photos. Maybe they should look the same. I don't know. But it's good to remain open to the situation, the possibility that there might be an honest error, and then hope, of course, that the journal will take any action. Maybe a correction would be good in certain cases, or maybe not take any action. But in most cases, I feel that either a correction or a retraction should follow. But unfortunately, I have some experience now in reporting these papers, and I know that after 5 years of reporting the 800 papers I found about 5 years ago, that most of these papers have not been corrected or retracted. So only 40% in total have either been corrected or retracted, but 60% of the papers that I found about 5 years ago and reported all of them to the journals, 60% of these papers are still untouched, and they have a big problem, and it seems that the journals do not really take any action. So I've written to the editors, and maybe they will acknowledge my email, but they have not taken any action. So based on trying it the official and polite way, I have taken things to report these papers online, and I'm mostly using PubPeer, which is PubPeer.com, a website where you can report problems with papers based on the unique identifier of a scientific paper, the DOI. And for example, here you see a paper that has, in my opinion, a big problem. This paper has been retracted, but there was a lot of data duplication going on. So I put my illustration on PubPeer, and this is moderated, so you have to remain objective. And what is unique about PubPeer is that you can install a plugin that will work with your browser, either with Chrome or whatever internet browser you have. It will also work with Zotero, which is a reference citation manager. And that means if you do a literature search and there is one of the papers that you're finding in your literature search has a PubPeer command, you will actually see that in your PubMed search, for example. You'll see a green banner, or you will also see in Zotero, you will see that paper has a PubPeer command. So you can click on that and see what other people had to say about this paper and see if there's a problem or not. And so for me, it's a good way to alert readers for potential problems. I sometimes also take things to Twitter. So the science paper I just talked about, I will post that on Twitter in the hope that that will encourage the journal to take action, but they have not done anything yet. Here's a paper that I found in Nature, published by people working at Harvard. And this paper actually got retracted about 9 months after I published this, this online. And so, yeah, these are, I do take things online, not because I want to do a trial by Twitter, but because I'm frustrated and I want to show people that there are potential problems with papers, and we should alert the readers. So I have a couple of examples of other types of problems that I found in papers. So the previous examples that I've shown you were all for images that were that had duplications, but I've also come across papers that have other types of problems. And in this particular paper, it was claimed that if you received the HPV vaccine, so that's the vaccine that prevents HPV infection, it's a vaccine that in the United States, at least, is given to young children, well, at the age of around 10 to 18, excuse me. And it's preventing HPV infection. And HPV, the human papillomavirus, can cause cervical cancer, anal cancer. So actually the HPV vaccine is a vaccine that can save people from getting cancer. So it's a, in my opinion, a very good vaccine. But since it's given to young children, parents, and since it's a virus that's transmitted through sexual contact, a lot of parents are hesitant to have their 13-year-old daughter vaccinated against what could be a sexually transmitted disease. And so I think most parents of children who are aged 13 are not really, don't want to think about their children being sexually active. And so there has been a lot of hesitancy to get children vaccinated with this vaccine. While in reality, it actually is, yeah, again, a beautiful vaccine that could save people from getting cancer at a later age. So this particular paper claimed that women who had received the vaccine when they were younger, once they got older, that they were that the vaccine caused them to be infertile, to not be able to get children. But what they did is they only showed the data for women up till age 29, and they said, well, the children, the women who had received the HPV shot did not get as many children as the women who did not receive an HPV shot. And so, yeah, that looked alarming. It looked like, oh, wow, these women had received a HPV vaccine and they didn't get children. That is, are they infertile? And that sounded very alarming. And it's used a lot on a lot of anti-vax boards. But the problem with this paper is that they only looked until age 29. So in the United States, where this paper was based on, women who do not have a college degree will get children at an earlier age than women with a college degree. And so women with a college degree typically will get their first child at age 30 or a little bit higher even. And so if you compare these two groups and you look at you look at their education level, where is it, college degree, there's actually a big difference between these two groups. So the group who had received the HPV shot had a higher percentage of college graduates than the women who did not receive an HPV shot. So basically, by cutting off the data at age 29, they were leaving out the women, the pregnancies of the women who had a college degree. So basically, the women who had received the HPV shot were on average more college educated and would have had their children at a later age 30 or higher. So they cut it off at age 29. And in my opinion, this was like leaving out data, so data fabrication, data falsification. And finally, this paper got retracted because they just did not include the older women. They didn't have had their first baby yet. So this paper got retracted, but still, you can see on a lot of anti-vax message boards that where people will claim that this vaccine causes infertility. It's based on this paper, but it's now retracted. Sorry, long story. But it's important to look at data and to see that sometimes data can be tweaked to bring a particular story and create a false story, actually. So another paper that I found claimed that 5G, you know, the new telephone band, that induces coronavirus in skin cells. And this didn't make any sense because it had a beautiful sentence that sort of claimed that the radiation could go into a cell and then just produce COVID-19. And people are saying, why doesn't it produce $100 bills? That would have been equally likely, but no, it specifically said that these waves cause COVID-19 to emit. There's all kinds of errors in this paper. It had beautiful diagrams that didn't really mean anything. It had a lot of formulas that looked very impressive, and it had this huge graph saying that the probability of something of DNA to happen goes up to 100%, and it just did not make any sense. And luckily this paper got retracted as well. I mean, if you make a grandiose claim, you have to come with big amounts of evidence, and this was just not evidence. Like, anybody can draw this graph. There was no actual data in this paper. So there's all kinds of other things that could go wrong with scientific papers that could be considered science misconduct. There are people who review their own papers by setting up false email addresses and then sort of claiming that they're reviewers. There's people forming big pacts with each other and promise to each other that they will review all their papers favorably. So sort of create a peer review and citation ring. And lots of papers have been retracted with that. You can read all the stories on Retraction Watch. And I've worked with people who claim to work at particular institutions that they just seem to have made up, the institutions that do not exist, but just lead back to their own private home address. And like in this particular case, this person set up a completely fake university that doesn't exist, but they have a whole website, and they created a lot of put a lot of effort in trying to convince people that they work at that university, but the university does not exist at all. So these are all kinds of strange type of people. And some of these papers are published in regular publishers that seem to be legit. But this particular person seems to publish a lot in journals that are predatory. So these are journals that really don't care about scientific content, but they care about getting money. So these are what a lot of people call predatory publishers. These are publishers that care more about making money than about the quality of the scientific papers that they publish. So they make misuse of the open access publishing model, in which the author pays the fee and then the publisher publishes their journal and makes it freely accessible for everybody to read. Now, that's a great model. It's a lot of journals now are switching to the open access model, like PLOS ONE, for example, is a very well-known journal that is completely free to read, but the author will pay for it. And that's a legit journal. But some predatory publishers make misuse of this model, and they publish, but they don't do any real peer review. They basically will publish whatever you send them their way. And so that could be a very crappy paper, or it could be people who have very strange ideas, like the guy who set up his own university, and or even companies who will think, okay, now we can publish our results and we can say it's peer reviewed, but actually it's not really peer reviewed. We just paid a publication fee and the journal published it, but it's actually not a very good paper and it should not have been published, should not have passed peer review if it had been sent to a legit publisher. So it's a huge problem, because there's a lot of papers being published that are just weird ideas or crappy science or just not good in general. And these are published by these predatory publishers, and they're really hard sometimes to distinguish from real publishers. But usually their peer review is very fast, or within a day. Or their editorial board does not exist. They sometimes use photos from legit persons and say that these persons are on their editorial board, while in reality these scientists don't even know that they're being misused, that their names are being put on their editorial boards. And so it's a lot of it is fake, and a lot of it is just not very, very poor quality. But it's hard to get rid of these journals because there's no yeah, it's hard to distinguish them from real journals. And basically the only way you can really tell them apart is, in my opinion, for biomedical papers, if they're included in PubMed. Most of these journals are not, but there are also journals that are included in PubMed that seems to be predatory. So it's very hard to distinguish them from legit publishers. And then finally, so my last topic is paper mills. And so paper mills are a huge problem, and they're almost like an organized crime organization that pumps out completely fake papers, papers with experiments that have never happened, and fake plots and stolen photos. And these organizations sell these papers specifically for medical doctors who work in clinical hospitals in China. And so the paper mills I'm familiar with and that I've worked on together with a lot of the people I've mentioned on one of my first slides, it's not that Chinese people are more fraudulent than other persons, but there's a very specific requirement in China that if you want to have a good position at a Chinese hospital, you have to have a paper published. Now, a lot of clinical doctors, a lot of medical doctors do not want to do research. They want to help cure patients. And so, but they still need to publish a paper. That's a very hard requirement that they have to fulfill. But they don't have time and they don't have a lab to do research. They still have to work 80-hour clinical shifts in a week, and they just don't have the time to do research. So how do you go out of this impossible requirement? That is, they can buy a paper, and so they will pay an amount of money, a big amount of money, and then their name will be put on a scientific paper that is published by one of these paper mills, so one of these factories that produce fake papers. There's lots of papers written, lots of articles written about this, and together with a lot of people that I've mentioned on the first slide, we have identified several of these groups of papers that all appear to look very similar. So here are two papers from what I call the tadpole paper mill. And I was not the first one to discover this. This was Jana Christopher, Jennifer Byrne, and Smat Clyde and Morty, who have all worked on this. And I've only did a little bit of contribution here. But I want to show you these two examples. So these are two different papers, two different journals, two different groups of authors, but they have very similar Western blots. So we call them tadpoles. They look like the little baby frogs that sort of swim through the water. They have a very strange shape, very unnatural shape. But the key point, how we recognize that these papers are all produced by the same factory, is that if you look at the background of these two Western blots, they look very similar. If you enhance the contrast, there was a very specific background. It had a sort of a double stripe here, and there's all these things in the background that are the same. So the bands look different, but the background looked all the same, not across all these panels or across these two papers, but across 600 papers. And so they appear to use the same background, and you had to enhance it a little bit, and then you started to recognize it. And so we believe these are artificially generated Western blots that were put on the same background. And then we discovered all these papers had also some other similarities, but it was hard to tell them apart because they're not exactly the same. But because the studio that made these photos used by mistake the same background, we could catch them. But of course, now we also told the fraudsters how to not do it, because now I'm sure they will produce very similar photos, but use also some randomization to make the background look different. We've also found other papers that appear to come from a different studio, a different paper mill. So here are two different papers, both retracted. If you compare their photos, like they all use photos that come from the same group of photos. So for example, these two photos are almost identical, but they're represented as two different experiments. And if you zoom in, here are the two photos from the two different papers. If you look at this particular structure, that looks like the letter J, or maybe an upside down T or a T. You can also recognize that here, but it's upside down. So these two photos appear to come from the same bigger photo, like it's zoomed in and it's rotated, but it's the same photo. And so it's hard to recognize that this is the same photo. And I spent a lot of time starting to recognize these photos and scanning these papers. And this is a group of 125 papers. They were all published in the same journal, and they're currently all being retracted. So these all appear to be completely fake. And here's a group of plots. These are from 4 different papers. They represent, if you look at the axes, they represent very different experiments. But if you look at the group of dots here, you can see that all of these plots look very similar. It looks like somebody made a plot and moved a couple of dots to the left, to the right, or left out a couple of dots, added a couple of dots, put some new labels on, and voila, you have a new paper. But all these appear to be fake. And if you ask the editor to then ask the author to produce the original data, then most of them the authors will say, well, sorry, we don't have that, or we outsourced it. And then usually these papers get retracted. But it's hard to recognize, because if you just look at an individual paper, you would not know that it's a paper mill, but you have to really compare lots of papers and start to recognize these groups of dots to see that. So this is the Comb paper mill. I think it's currently at 200 papers that we are hoping that will be retracted, because they're unlikely to have contained real data. And here's another example of an error that we can only catch these papers because the studio that make these papers, they make also little errors. So they usually write their papers on a template and then just change a couple of, for example, they might change the cancer name, they might change gastric cancer to prostate cancer. And in this particular case, this is a paper about prostate cancer. They forgot to change the numbers of males and females. And so they usually will change the numbers here a little bit. So it doesn't look like it's the same paper. But in this particular case, it's very unlikely to find females with prostate cancer. And so here you can see that they write a template, they change all the numbers, they change the cancers, they change the non-coding RNA, and have a new paper. But in this particular case, they made an error. And similarly, we found papers with breast cancer where there were roughly 50% of the breast cancer patients were men. And that was also, of course, very unexpected. And so it's only then that we can catch these type of papers. But unfortunately, if they don't make errors like that, we cannot really catch them. We might suspect that this is a paper mill, but it's really hard to put a finger on it because there's no smoking gun. So this is sort of my last slide, and I want to sort of touch upon a bunch of problems. I might not have the answers to each of these, but there are more questions to think about misconduct and how we maybe can solve it. So I did mention a little bit about the percentage of misconduct, and I believe it's that around 5 to 10% of papers, scientific papers, might contain deliberately changed or fabricated data. And so that's a pretty high example. So if you see a paper and you don't trust the results, be aware that this could indeed, it could be an honest error, but in some cases it could be an intentionally done misconduct, the change of the data. And why do people do that? Why we all feel the pressure to publish, but most of us will remain honest and maybe tempted to leave out data, but we won't do that. It's better to keep track of it in your lab book. If you decide to leave out an outlier, why you do that? But why do people deliberately create fake papers? That is probably because they're put in a very hard situation. They feel, for example, like if you are a medical doctor in China and you need to have a paper published, but you're not given time to do research, I can sort of be sympathetic for that scenario, why people would buy a fake paper. Or if you work in a lab where your boss is a bully and tells you, I need those results by Friday and I need this experiment to look like this, I could imagine that maybe you are tempted to change the results and present your PI with the results that he or she wants, just in order to get out of the lab and get a paper published and then go on in your career. And if you try to be honest, maybe that means you'll be fired and you have to leave science or have to leave academia. And so there are hard situations where people are put in, and those could lead to science misconduct. But there's always a sad story behind these cases. And so I'm sympathetic for that, but I still think it's important to flag these papers and to retract them. But I also try to be respectful of the reasons behind why people do these type of things. Are we maybe also focusing too much on productivity? So as scientists, we're usually measured by the amount of papers we publish per year. That might be just one paper a year that is expected of us, or it might be multiple if you're a professor. But we are focusing a lot on productivity, and we're also focusing a lot on positive results. It's very hard to publish negative results. And so those are all incentives to push people towards misconduct, because we need to publish this paper. We feel this pressure to do this. Whose role is it to detect misconduct? I feel that it should not be unpaid volunteers like me. I find all these examples, and I've reported now 4,000 cases. I'm not getting paid for that. All the work I do online is the work I do as a volunteer. And should maybe journals pay more attention to when they get a manuscript, to screen it in a different way, not just do peer review, but also be aware that a certain, maybe small, but a certain percentage of papers might contain fake data. You have to be a little bit more alert, and you have to, as a journal, I feel, put a little bit more effort in trying to ensure that the quality of your paper that you publish in the end is good. I also feel there should be a more legal protection for whistleblowers. I'm currently being threatened by a researcher in France who I have found a lot of problems in his paper, and he's currently threatening me for harassing him. And I'm not legally protected. I feel that scientific discussion should not be fought inside the courtroom, but should be fought discussed in the scientific realm, and not in the courtroom. But yeah, I will see how it works out, but it's hard for me to deal with these legal threats. There's also a lot of conflicts of interest. So a publisher might not want to retract a paper because that could in the end cost them the citation of that paper. So it could harm the citation index of that journal. And an institution might not want to investigate the work of a professor who brings in a lot of grant money, so that they might also not be very motivated. So there's all these conflicts of interest where publishers and institutions are not really willing to investigate these cases. And finally, there's a tremendous cost for science misconduct, not just for scientists who are all involved in these cases. If you think about a paper that gets retracted, it's not just the person who has done the misconduct, it's also the other authors on that paper who might not have been aware, but those careers are harmed as well. And all the people who work in these labs and all the people who work at those institutions also are embarrassed and potentially damaged in their careers because of these cases. So it's affecting a lot of people, but it's also affecting science as a whole, because all these cases about science retractions are damaging for science and could help create a narrative that you should not trust science as you should not trust any science papers because all of them get retracted. And you can sort of see how that could feed into all the misinformation that we're dealing now with as scientists. And so it's very, very damaging for science. And so I don't want you to walk away from my talk thinking that all science is bad. Because I still firmly believe that science is the only way that can help us out of a pandemic or help us with climate change. I feel science can provide answers and we should trust science, but there is a tiny fraction of science that is not to be trusted, but it's still a tiny fraction. And hopefully you will be a little bit more optimistic, knowing that there's people like me who care about the quality of science and want science to be self-correcting. And so I hope you agree with me that we can make science better by retracting some of the papers that have very obvious problems. So if you like that, I would encourage you to follow me on Twitter. This is my handle, Microbiome Digest, and I will occasionally play a game called Image Forensics with that hashtags, and you can spot the duplications. I will remove the identifier, so it's not about the papers, it's not about embarrassing the authors, it's just as a game, like can you spot the duplication? And then, so the duplication is here, and if you mark it correctly, I will hand out the first person who has the right answer. I will give them an emoji medal, so you can earn medals there, and they're very wanted, so a lot of people like that. So with that, I will stop sharing and hope to take any questions. Thank you.
Okay, Dr. Bik, that was super. I have to tell you, I personally learned a lot. I had no idea about peer review fraud. I wrote here, peer review fraud and fake affiliations, paper mills. I had no clue, none. I have a PhD in soil science, working in the field for over 20 years. And, that really wakes me up a bit. One of the other things that really stood out for me in your talk was the example of the Wakefield vaccines, autism retraction, and the HPV vaccines. That's really relevant to what's going on today, and with the United States, at least, all the COVID anti-vaxxers or whatever. And this shows the importance and the relevance of your work. There's no question about it. When you put it in that context of these examples, like the HPV, I mean, we're talking about things people, and I think that shows the relevance of your work. There's no question about that. Yeah, there's actually there are a lot of things. I have a lot of questions. I'm going to see if there's some chat questions here. There was something. Before I look at the chat, I wanted to mention one thing. I was informed that you decided to waive your, I think it was $250 fee for doing this talk. Is that correct?
Yes.
Then, I think that's very generous of you, especially for us here in Brazil, with our situation and the difference between the dollar and the real and everything. It really is a big deal for us. So, the doctoral program here, the SND, would like to thank you very much for being so generous.
You're very welcome. Yeah, no, my pleasure.
Ok, bom, eu vou aqui, estou vendo os dados, as perguntas, the questions here. Okay, okay, it's written in Portuguese, so I'm going to read it here first. Ok. A pergunta é, doutora Bik, em todo esse tempo, com sua atuação brilhante, a senhora já recebeu algum tipo de retaliação dos autores das fraudes identificados? The question is, have you, in all your years here of work, your brilliant work here, the person wrote, have you received retaliation from fraudsters, I guess you call it, authors that have been identified as committing fraud?
Yeah, I mean, not in a personal way. Nobody ever walked up to me and punched me in the face, although I could imagine that some authors are not too happy with what I'm finding. So, but I have received some nasty replies on papier, or not too much by email, like that actually. Yeah, I haven't received a lot of emails, or personal emails or so, but yeah, there have been replies on Twitter and on papier that will, instead of answering my questions, my concerns about figure 1A and 2B, instead of that, they will attack me. And so they will look at my life, they will look at my resume, they will look at all my papers, and they will try to find errors in what I did. And so even if I make a typo or post, by accident, the wrong link or so, my God, I'm going to hear that. Like, and in particular, because I have worked at a company, Biome, that is the founders of the startup are currently being accused of fraud with medical insurance billing. It's very complicated, but the two founders the company has been raided by the FBI. And so they will find that, obviously, that I've worked at that company. And I have not been questioned by the police at all, but I left the company before this all happened, but they will accuse me of being, having worked at the company and actually being responsible for the fraud. They will accuse me of working for pharmaceutical companies. And in particular, that one doctor in France who claimed that hydroxychloroquine is going to save all COVID-19 patients from being sick, which I imagine also had a lot of repercussions in Brazil. So that doctor is very angry with me and is now threatening to sue me for harassment. Yes. So it's not very personal, but it's very scary nonetheless.
Então, eu vou... Minervino, eu preciso traduzir ou fazer resumo da resposta em português?
Não, Troy, a gente pode manter, inclusive, somente as perguntas em inglês, não tem problema, não. Tá? Depois a gente vai colocar as legendas. Não precisa nem traduzir em português. Se a pergunta estiver em inglês, já faz direto em inglês.
Ok, tá, mas tem alguns aqui em português, então eu vou ler.
Tá,
tudo bem. Mas eu não preciso fazer resumo da resposta, então.
Não, da resposta não.
Okay, so the next question I have here, if you kindly permit, is, let's see here. What is the difference between excluding data obtained in some samples that gave very different results from those that had been occurring, and discarding data that did not give a desired result? So did you follow that? Or
that sounds the same to me, but basically if you leave out data that doesn't match what you think should have happened. So if you, for example, if you make you make a curve and all your data are nicely on a line, and then there's one outlier and you leave out that outlier, is that science fraud or not? I think that could be science fraud, but like when I have done that, or we all have had that occasion where that happens, where one data point just doesn't fit the line. So I've repeated the experiment and then it was good. So I sort of thought, well, maybe I pipetted wrong, and I will leave it out, or I will repeat the experiment. I had not expected this to happen, but I will take notes in my lab book. I'm not going to hide it. I'm just going to repeat it, and now I know, okay, now it went right. But if you really leave out data, for example, the example that I showed you where you leave out the older women because they did not have their first babies yet. So if you really leave it out to fit a particular narrative, then that is science misconduct. But it's sometimes hard to draw the line, and did a person do that on purpose or not? It's hard to prove that. So I hope that answers the question, because the two things that were posted here sounded like the same.
Yeah, they sort of did, but yeah, that gives us a nice insight. It really does. Thank you. So the next one here, I don't know if you can see these questions, I suppose here.
But you can read it.
How guilty are the editors and reviewers of the journals for not observing misconduct and allowing articles with manipulation to be published?
I don't think they're necessarily guilty. I think in a lot of situations, the editors might not have seen it. For example, the paper mill examples, if you look at the individual paper, an editor might not realize that there are other papers that look very similar, but they might have been handled by different editors. Usually a journal will have multiple editors. And so if they get one paper that is handled by one editor, another paper is handled by a second editor, it might take a while before they realize that they're getting a lot of very similar papers. And so you cannot initially blame them, but at some point I feel somebody should have thought like, hey, they're all looking very similar. The number of patients changed a little bit, but the data looks very similar. Yeah, I'm not sure if they're guilty. I think a lot of people are just not aware. They're very gullible, which means, they're easy to influence, they're easy to believe whatever is sent their way. And I compare it when the first time you get an email and you hear, oh, you have won $20 million, you only have to give me $10,000 and then I will give you $20 million. If you hear that story for the first time, you're like, whoa, I won so much money. I'm gonna give that guy so much money. But once somebody points it out, that's a scam, don't do this, then you're like, aha, this is a scam. So now you recognize it's a scam. So what we're trying to do by publishing our findings on paper mills, we're trying to warn other editors. And I feel by now they all should be very aware that a certain percentage of papers might be completely fake. So yes, I do feel they're starting to, we can hold them accountable. They should do this.
Right. I think then I'm going to wait to go to the next question here and sort of interrupt. Just to continue with your thought, I think that as your work and the work of others continues over time, in the long run, editors are going to have to be held more accountable, because there will be less possibility that you could be as unaware as I currently am about these topics. So, in other words, you are in fact doing science, because science progresses in baby steps, and you are helping the editorial world as a whole become more aware. In the long run, they're going to have to be held more accountable eventually.
Yes.
And that leads me to one of I have a bunch of questions. I won't be able to ask them all. It leads me to one of the questions that I actually wrote during your talk, which has to do, you were just talking about paper mills. Well, the question really is, you only have a limited amount of time. So why bother focusing on predatory publishers? I mean, nobody's really going to cite them that much. I mean, not high quality science. So wouldn't it then be better for you to focus your time on high impact factor journals instead of waste your time with these losers?
Well, yeah, I have had that question. I don't feel it's a waste of time, because I do want to warn authors that that predatory journals exist, because some inexperienced authors might fall for it. And so I will post occasionally on Twitter, like, oh, I've had this invitation, and this is a new new predatory journal or a new publisher that nobody has flagged this before, but I recognize this as predatory. And so I will talk about that, and I will make. I don't feel it's wasting my time, because I'm actually trying to prevent other people from wasting their time. But relatively, I don't spend a lot of time on predatory journals. Most of my time is on actually journals or papers that have been published in PubMed indexed journals. So it's only a very small fraction of my time, and I still don't feel it's wasting my time, because it's all unpaid, so I can choose myself. I don't have to listen to anybody telling me what to do. I will pick and choose what I want to work on myself.
Okay, excellent. Let's go to the question here that's been written in the chat then. Let's see, what should we do with articles that have already been published, that have many citations and for which the methodology was based on an article that some years later was retracted due to misconduct? So you follow that, right?
Yeah, so I sort of see two scenarios. Maybe there was misconduct, but in general, the content of the papers were still valid. And so other people might have cited the paper, but also were able to replicate results. So I think in a case like that, of course, the paper gets retracted, but they will still be, it was still a valid paper. Maybe one part of the paper was misconduct, but the rest of the paper was untouched, because sometimes in papers, different authors work on different parts of the paper. So maybe one part was bad, but the rest of the paper is still good. And even though the paper is retracted, it could be republished with, in a new journal or a new paper. And so that sometimes happens where it gets republished. But there's also cases where I've seen misconduct and flagged it, and papers maybe get retracted. And then other people will write me like, I have never been able to replicate these results. This was, the author claimed this and that, but like the step paper of Haruko Obokada, nobody could replicate these results. And she claimed she could do that. But then when she was actually allowed to replicate her results and somebody was watching her, she could not show the results. So she could only do it when nobody was watching her, and then it worked. But when somebody was watching her, she could not get it to work. And so in many cases, these papers are not reproducible.
Okay. Well, then I have a couple of questions here for you, and I don't know how much time you plan
I
on
can
spending.
stay. I can stay longer. Yeah.
Okay. Then I have one of the big questions I have is I wrote this: science is a collective undertaking. In this sense, wouldn't it be true that a paper before being published should receive acceptance by all the authors, and that any alleged misconduct should therefore be collectively shared? I mean, you got a paper with 10 authors. I mean, they probably had to consent to this being published, so wouldn't they all be collectively, I don't know, guilty or involved?
It's a great question and hard to answer, because as an author, all authors on a paper are responsible for the content. So but I don't think they should be punished for misconduct. It's sometimes maybe one person is doing the misconduct. So of course there is a responsibility of authors to look at the paper and look at all the figures, even the figures they have not made themselves, and sort of have a good feeling for if it's fake data or not. But I don't think people who were not responsible for the misconduct themselves should be punished. Like I feel, if the misconduct can be leading to one particular author, then maybe that author should be fired from their job. But I don't think that all the other authors should be fired, but they are responsible for losing the paper in terms of retraction. Yes,
Okay.
like the same way, like I wasn't responsible for the fraud at Biome, but I will forever carry this on my resume, and people can always say, but you worked at that company and you should have known better. And yeah, I mean, I guess that you could hold it against me, but I'm not responsible in that. Like I didn't do the misconduct myself, but I will have to carry the results for the rest of my life. Yes.
Well, one of the solutions I've thought of for this is some article, I think like the Proceedings of National Academy of Sciences in the United States, I think, in other journals. At the end of the article, they will list that E. Bik was responsible for the concept, the idea. T. Baldini did the laboratory work. So then, with it being very specifically stated who did what, maybe that'd help if there's some eventual problem down there. Maybe all journals should adopt that policy.
Right. And more and more journals are asking the authors to list each of the person's responsibility. And you could even break it down to figures, like figure 2 was made by such and so, figure 3 was made by such and so author. So yes, that's a very good development to sort of hold people responsible. But for example, there was this big paper about the Surgisphere data. I don't know if you're familiar with that, but that was a paper in which one author claimed to have a data set that showed that hydroxychloroquine had a lot of side effects and was not working with COVID-19 cases. And so he claimed to have collected this data at a bunch of other hospitals, and he found a couple of authors who were all willing to become an author on his paper, but none of them had seen the data set. And so they just put their name on the paper, helped him write it, but they never asked him, can we see that data set? And so it turned out that there apparently was no data at all. And so it's still unclear, it's still under investigation, but the paper got retracted. It was published in the Lancet, and so it was a big, big scandal. But none of the authors had seen the other authors had not seen the data. They could have asked for it, and they could have been a little bit more suspicious if the other author is not willing to share it. So yes, you have a responsibility there as an author.
I would consider them. They have some guilt if they didn't take the initiative to at least verify that there were data, that kind of thing. And you just mentioned hydrochloroquine again, and that gives me an opportunity to segue into my next question, which has to do with highly politicized topics. I thought of this question during your talk. Are there more positive hits, if I can call them that, related to highly politicized topics such as the HPV vaccines, autism vaccines, the 5G, which there was lots of places around the world. Switzerland, for example, is opposed. There's a whole group opposed to the introduction of 5G. Do you get more hits on these highly politicized topics because there are scientists that are very biased for or against these topics?
Yeah, there's cases like the HPV vaccine paper, for example, that was not published by a person who was an epidemiologist or like a microbiologist. It was, I forgot what her background was, but like it was just published by one person and not a person who normally would have had a lot of background in it. And so it was a person who was known to be an anti-vaxxer. So in this case, it seems that a person had a very particular political agenda. They were very biased before they started the study already, and they might have deliberately left out data. But in other cases, good science just becomes very political. Like we've seen in the past year that people who are doing honest epidemiology work or virology work are being sucked into political discussions that they don't want to be in. But yeah, everything became very political and everything became very divided in the past year. And so when I wrote my critique of the hydroxychloroquine paper by the Raoul lab, I was not particularly in favor or against hydroxychloroquine. I just thought this was a bad paper. And, you know, there were a lot of flaws with it, but I was automatically labeled as being anti-hydroxychloroquine, but I wasn't. Like, I just thought it was a bad paper. So even though I didn't want, I was sucked into this, you know, you're either here or you're there. And that's not how science works. Like, there's a lot of gray zone in the middle, and most scientists realize that science is very slow. Science should be slow and should be never has a complete yes or no answer. That's not how science works.
Very good. Excellent. I'm going to check in with them and see if there are people that have other questions here. Antônio, tem outras perguntas? Eu ainda tenho.
There is one last question in the chat. It's what your opinion about papers cited fake papers? So your paper is okay, but you cited one or two fake papers. What's your opinion about that?
Yeah, that's bad because these fake papers are becoming part of my brick wall of science. Like they're bricks, and other people build their science on these papers. That's horrible because this research probably has never taken place, and other people believe it's real, and so it's just going to pollute the whole field of science. So in particularly these fake papers appear to have been focused on non-coding RNAs in cancer. So it's not really directly helping a patient. It's just, you know, some experiments in the lab, and this little piece of RNA might be involved in, you know, might be higher or lower expressed in cancer. So it's not really directly helping a patient, but in the end, it could become part of a narrative. And yeah, so I just hope that it's not replicable. But yeah, there's a lot of papers that are being cited. And so by posting these things on papier, hopefully we can alert readers that you should not trust automatically these papers too much. And that's the best we can do as whistleblowers to flag these papers on papier. So I always encourage people to have a papier plug in your browser. So you'll see that papers have had certain problems, and to post it yourself. If you find problems, don't assume I will post it because I cannot post everything. I'm not Superwoman. I have to rely to other people to also post concerns about papers.
Yeah. Okay.
If it was me, I will issue a retraction and remove the paper from my reference list. It's an option, don't you think?
Like if you have based your research on a fake paper, then you should probably rethink like how much is your interpretation of your own results influenced by the previous papers. And it might not maybe that paper didn't really contribute much to your own thinking, but yeah, you have to maybe retract your own paper if you base it too much on a fake paper. Yes, that could be the outcome.
Okay.
I think we have time for one last question because we have a presentation in 5 minutes. So I think one last question.
Okay, then I have a question, and it's actually a kind of a personal question, if I could here. You, you were obviously very courageous, leaving science and taking on a voluntary role.
I'm still in science. I didn't leave science.
Right.
I don't feel.
Right. That's where my question's going.
I
You got
didn't
into-
drop out of academia either. No.
That's what I want to know. You know, it was a courageous step and everything, but do you feel like you're still making a real contribution to science, and just as if you still have been writing papers, working in a laboratory? Do you feel that way?
Yes, I actually feel that I'm contributing much more to science than I ever did when I worked in a lab, because I feel the work that, I mean, I haven't started this, but I do this work visibly, like I do it under my own name, not as an anonymous person. And I feel I've made a huge contribution to science, because I know that editors are changing the way they look at papers. They're changing the way they do peer review. They're changing the way that a paper has to fulfill certain requirements for showing original blots and things like that, and not allowing splicing. And all these guidelines for figure preparation are changing because the work that we're doing. And so, of course, we're also telling the fraudsters how to become better fraudsters because they're going to cheat no matter what. But we're hopefully have made it very visible that there are fraudsters in science, and we should be more aware of it. And I feel that's a big contribution, much more that I could have worked by working in the lab.
Sure. I don't know, Antonio, se nós temos mais minuto. If we have one more minute, there's a question in the chat here. Can we do this last one? Podemos fazer?
Yeah, you can do it.
Okay. Elizabeth, I think you read that the question there?
Right.
Can you, okay.
Yeah, I'll read it. So this month at the Young Brazilian Academic of Science, there was a debate about whether major magazines have discriminatory content with South American authors. Do you think this possibility exists? Yes, I do think so. Because I have been an editor for a journal, and I found it much harder to find reviewers for papers that were from non-native English-speaking countries. So there is an assumption, unfortunately, that if the authors are from either Asian or South American countries or African countries, that the quality of research is going to be lower. And that is something that is really hard to fight, and there's a lot of unconscious bias that a lot of reviewers have. And so it's tough, because like maybe you could sort of say that if the quality of English is lower, that doesn't automatically mean that the quality of science is lower. Like English questions about the language are easy to address. You can use a translating service. As a reviewer, I will have some helpful suggestions if I feel that the language is not very good. And so to improve the paper in general, but it should not affect the way that reviewers are willing to accept papers to review or to allow them to pass peer review. So it's tough, because we can signal that there is discrimination, and I cannot solve that myself, but yeah, and I'm not sure how to solve this problem, but I do think that's a very realistic thing. Yes, and for example, with these papers from China, there is now there's editors who say, I'm not gonna, if it comes from China, I'm not gonna review it. Like that's actually going on, that I know for sure, that certain journals are not taking on any submissions from China. So yeah, that happens anywhere in the world, unfortunately.
Well, one way around this could be that a cooperative partnership with international researchers. So in other words, do research projects that involve American, Dutch, what have you, other, international research to try to get around that, maybe. Possible.
Right. Offer language, help with languages as a free way to, if authors are struggling with the language, that's a solvable problem. And I feel that things like Google Translate are gonna be some, they're already improving a lot, and that's going to be a freely available service for a lot of people. But yeah, I don't know how to get rid of biases. That's a big problem to tackle here in this Zoom meeting, I feel.
Okay, try. Yeah, I believe he has some internet issues. We are in the middle of the Amazon, so it's internet. It's a problem here. It's not a little thing.
So, bom, tem uma pergunta sobre inteligência artificial, but I don't know if we have time or not.
Yeah, we need to finish, because if you don't finish, we will delay the other presentations.
Okay, well, I think then we'll close here. I'd like to thank you, myself, and on behalf of the SNED PhD program here at UFOPA, we thank you very much for opening our eyes to this topic, which I frankly really had almost no knowledge of whatsoever. And so I'm going to be more aware of this and take this into consideration as I progress in my own scientific career. So thank you very much, Dr. Bik.
Thank you so much, Troy, and thank you, Antonio, for inviting me, and was my pleasure.
Okay. Thank you, Elisabeth. Have a great afternoon. Bye-bye.
Bye.